As the name implies, system tests validate that the entire application functions correctly. PyTest isn't just for unit tests. For a system test, we could spin up our CRM Docker containers, then use PyTest to execute a workflow that tests the functionality of our CRM app as a whole. Specifically, we can integrate the popular Python request library that we've been using for much of this course. Each individual test can make HTTP GET or POST requests to the different Docker containers running locally, then check the HTTP status code and body for the expected result. We can include negative tests too, such as a GET request to a non-existent URL, then assert the status code returned equals 404. System tests are both necessary and powerful, but are slow and more complex to set up. Linters and unit tests run very quickly and don't take long to design and implement. System tests take more planning and setup time. This is why we run them after the faster tests have already passed. Let's combine Docker, PyTest, and the request library to build a solid system test for the GlobalMantics CRM app. Let's waste no time and dive right into our system tests, which I've named testsystem.py. We are using the request library again, except rather than interact with Cisco product REST APIs, we'll use it to talk to our Dockerized CRM app. The first test case simulates a user navigating to the CRM webpage using HTTP GET. If you recall from the previous module, our Docker Compose infrastructure spun up 3 CRM containers using TCP ports 5001, 5002, and 5003. After defining some basic HTTP headers for HTML text, I use a for loop to iterate over those 3 TCP ports. Within the loop, I issue an HTTP GET request to the local host using the different port numbers, allowing me to test all 3 containers. Once the response comes back, I assert 2 things. First, we must get status code 200, not just any non-error code. I'm also asserting that the text enter account ID appears inside the body, which indicates our web form has the correct prompt. Remember that negative testing is also important. In the next test, everything is the same except the last few lines. I try to navigate to an incorrect URL using bad.html as the target. I expect to get an HTTP 404 status code in response, and the words "not found" should be present in the body. This ensures that our website is behaving correctly. You might think that I'm doing too much copy-paste between test cases, and you'd be right. We can use functional decomposition to write tests. To handle HTTP POST requests, I've defined an internal function named _post_account to handle the heavy lifting. It takes a dictionary that expects an account ID and an optional account balance if the account is valid. Notice that the actual test cases are only 1 line long and they just pass in different dictionaries to the helper. In the good case, account 100 should have a balance of $40. However, NIC 123 should be invalid and no expected balance is supplied. In the helper function, I define some basic headers which are needed for the HTTP post. You can always reference the Wireshark captures from the previous course if you'd like to see how I reverse engineered these data constructs. I then use the for loop to step over each TCP port, issuing the post requests in sequence. The body of the post request isn't JSON, but is just plain text containing a key value pair that the controller will process. The post should return HTTP status 200 every time. If an account balance was specified, we assert that the specific balance is present in the HTTP response body. If the account was invalid and we didn't expect any balance, let's ensure we see the friendly unknown account number text in the response instead. To run this, I'm going to use Docker Compose up with the -- detach option, allowing us to keep typing commands. We can use Docker Container LS to get a list of running containers. Despite the ugly output, we can see all 3 containers are up. They are also running on their assigned TCP ports as expected. Let's run our system test now using PyTest in verbose mode. Excellent. All 4 test cases have passed. I'm reasonably confident that our app is working correctly. Let's do a clean teardown using Docker Compose down. In the next clip, we'll automate this entire test pipeline using Travis CI.